It's really nice. That's my son. So big. He's in high school. Get him started. Interested in networking? I couldn't get my kids. So boring. The room is really empty. Give it one more minute. Big message, Tony. Okay, let's start. Welcome to IETF 120 in Vancouver. We are Rift Working Group chairs, Jeffrey and myself. Please make sure you've read Not Well. It's a reminder for IETF policies, and by participating in IETF, you confirm that you are familiar with the policies. So please make sure you're familiar. ISG specifically also asks us to remind you, please be nice to each other. Don't do to others what you wouldn't do to yourself. Agenda for today, we'll provide a quick update on what's going on. Then Tony will talk about adaptive route. We'll have Jordan talking about Kivali Auto VPN updates. And then Jeffrey will talk about our future plans with SR multicast. And we'll discuss charter that is to go to ISG for update. So we had 3 deliverables in initial charter. Basic application, it's already in RFC editor queue, so it's difficult to believe, but after all these years, we are almost there. Applicability statement, similar state, it's in RFC editor queue, and Young model is in ISG evaluation. It's pretty simple, clear document. We don't expect any surprises here. So there are 3 other working group documents that are in progress and that are going to be made as part of the charter. So it's key value structure and processing, VPN, and segment routing, and multicast SRv6, and all new work that we are doing now. We will discuss after chartering and how it's going to progress. Yeah. Who are you?
He doesn't care. This is for Oxford.
Yeah.
Then you guys start.
I'm so jet lagged, I just fell asleep in the meeting. So if you want to yank my chain, you have to go.
Well, you're up.
Don't ask me for it. You won't get. So now it's your time to talk. And you could have the flicker. Power is yours.
You trust me with this? Hey. So I'm a sharp-dressed man because airline lost my luggage. So here goes Banana Republic model. All right. So that's of course because everybody's pestering me to do something for the AI, which will take over the world and I don't know, generate endless money and probably heal cancer. So the draft is called, of course, it's a joke, Adrift, because there is this buzzword of adaptive routing. It fits well. So we're chasing the AI fad. Well, it's really just traffic engineering, right? In yet another guise, and all these people stipulating that AI loads will not change will be into a rough surprise. Same thing happened on cloud computing. The patterns will change and will be in traffic engineering land again. So the problem is two major aspects. One is simple, one is less so. And actually, I don't even know whose idea that was. Probably Dimas, because we had a couple of meetings and chewed through stuff. So of course we have to flood a bunch of TE metrics around, right? That's kind of the simple stuff. But that leads to fairly simple southbound computation because we see the full topology, but stuff becomes more interesting if we go northbound because we don't have the full topology on the leaf. And if we do, then we basically die again in the scaling battle. So the annoyingly trivial part is to add the TE metrics. So if you look at the draft, we end up with a new tie type. And why we add the new tie type? Because it would be not very wise to put all this stuff into the normal node tie, in my opinion, right? We want this thing going fast. And this is additional stuff that can go on low priority in terms of flooding. So what is in this additional node tie element? Basically per link TE metrics. So first some general one, and then per traffic class, because of course we have to split the whole thing up into traffic classes. Bandwidth is already encoded on the node tie today because we use it for very rough, balancing, but it is not blowing up bandwidth per link. It is really just node to node, how much bandwidth is available, because it's good enough for just normal forwarding. Like I said, this stuff will be flooded low priority to keep, the convergence of basic reachability blazing fast. It floods at the node tight scope. People who know the spec know what it means. So there's no magic. We don't have to construct anything special. And that leaves the southbound. So the top of the fabrics is the full topology underneath, right? Including TE metrics now. But the northbound, of course, just only see kind of the two hops horizon because it sees itself and it sees the node above it advertising the TE metrics. So there will be even a picture. So the computation, right? When we are at the top of fabric and we want to get to this little guy at the bottom and we have some requirements bandwidth-wise. It's kind of trivial because we have all the traffic engineering metrics. So it doesn't really change from what IGPs are doing today. And saying it's simple is of course a brazen lie, because this kind of computations always lead to something called fishtail problem. So if you look at the green path and the blue path to reach the node, you end up with 10-10-1 and 1-10-10, right? So you have possibly bottlenecks at different places, and add to that like delay, and then you ask yourself, okay, how much bandwidth do I need and how much delay? But thankfully we have actually not T's, but we have a PCE working group, and they're worrying about the stuff since years. So the stuff is kind of understood, right? And not much can be done, right? So it's a CSPF, constrained SPF problem, RSVPT again, modulo that we still want probably to keep the valley-free routing. Otherwise, we need some kind of state and steering on the substrate, which will of course become enormously expensive, no matter whether you run MPLS or you run SRv6 or any kind of flavor, where you start to keep states on the node and steer the traffic. Okay, now for the interesting part. So if you go northbound, we don't have the full topology. So for very flat fabrics, it's fine, right? The leaf sees the TOF, and it kind of sees all the metrics from the TOF. But as soon as the claw starts to go higher, or on Dragonfly or something, the nodes below, low in the fabric for scaling purposes have only partial information. They see itself and they see a node above it. And that's the horizon. So we were talking how to deal with that in terms of steering traffic engineering for all these, well, AI workload, whatever. And funny enough, we already have a mechanism. We have negative disaggregation, and it looks very similar. So negative disaggregation is in the kind most extreme case of this. Negative disaggregation basically advertises southbound, don't go through me. I cannot reach the place. We introduced something which is also a tie type, okay? And it is being flooded like a prefix, like a negative prefix. And instead of just saying, do not use me for this prefix, it has a preference. It says, compared to other guys that are at the same level as I am, prefer me less, okay? That can be transitive, right? Just like negative disaggregation, but it doesn't have to be. And it can be actually generated at any level. So if a node looks at its neighbors and 2 levels up and goes, whoa, I cannot really get to this prefix through these 2 levels up. I have much less resources than my neighbors at the same level. Then I will generate the stuff and push it downwards and say, look, don't go through me because there is congestion up there that you don't see because of the lack of topology information. So the computation itself of the FIP is very similar to negative disaggregation computation, which is done today, which means that the negative computation, though most people will be familiar with it, basically looks at negative advertisement and removes those gateways from the next hop, right? So it basically takes a prefix which is negative disaggregation, because this prefix may be not advertised normally, and it says, okay, give me as next hop the less specific, whatever it has as a next hop. And then look at the negatives and start to remove the gateways, right? That say, I cannot reach this very specific prefix through me. So this will still run first, but then we run on top of that this preference computation. So we basically look at these prefixes and we say, oh, this guy says it should be less preferred. So whatever still the gateways in the next hop are, they can be weighted again, right? To say like, okay, put more traffic onto this guy. And now, so the more interesting stuff, or what tails out of that. So what's very annoying, this spins a new major schema version. We cannot make it the same schema version because the tie type, the additional node stuff, has node scope. And we say we can only keep major schema if you flood something that is weird, but it has prefix scope. Because if you don't understand what this thing is, you don't know what is the flooding scope. So we said, as long as you add weird thing, people don't understand this prefix scope, it's fine. But now we have all this preference, right? For the node south, we have a prefix scope, but to add all these traffic engineering metrics, we have another kind of node scope thing. We could avoid that by sticking all this stuff into the node tie, but I do not consider it wise from a long experience with this kind of stuff. And what falls out of that, I mean, in any other discussion, this is coarse, right? So routing will never do this adaptive routing, no matter what people think they can achieve with incredibly fast floodings and so on. It can only do coarse balancing, right? For something like traffic class at whatever, hundreds of millisecond resolutions at best, probably more like towards a second. So what will be needed always on those fabrics, and it doesn't really matter what we talk about here or other people spinning stuff, the source-specific congestion signaling, CAC, is of uttermost importance. And I think that will be always an L2 stuff. So what, 802, 11 BB, whatever the cooking, QBB, I don't remember.
No, none of this is used, and neither will be used.
You published something, right? What was this thing called? Something plus plus.
So HPC++ using invent telemetry to do switch augmented.
So that's expensive-ish, right? But maybe that's the way it will go. but I think it will be from the destination, um, a CAC message, so call admission control message back to the source. And if you end up on a fabric that does too much of that, everything will melt down, right? So judicious mix of both will be running, will scale on very large fabrics. You need this core stuff so you don't get overrun with a million things, but the fine grain will be still needed because this stuff will be never adaptive enough, as far as I see, right? So the draft is pretty fleshed out, but no, the computations are only online. Co-authors welcome. I think it's interesting work. Yeah, that's pretty much what I have.
Thank you. So few comments as working group participant. Number one, you don't realize how much you are right. I cannot show you or share test result, but eventually you will.
Oh, you mean how I figured out that that's what the stuff will be like? I don't know, 40 years of dealing with the same thing over and over again in the same, illusion cells.
You've been talking about traffic classes. So traffic class usually has some local definition on the device, right? It's how you define it. Routing protocol has no notion of traffic classes. What exactly do you mean?
I mean, 8 bits integer right now. So it's basically an index right now. Should we go into the definition of globally defined traffic classes? I'm agnostic. I was just thinking about protocol mechanisms so we can shove the stuff around. The semantics of the whole thing, I was pretty loose. So we can have an enum type saying whatever, this is the traffic class, this is the traffic class, and we pretty soon get into AL2, AL5,
Yeah, so traffic class today pretty much defined by DHCP setting, right? You take it, you map it into something.
Yeah.
Are you talking about multi-instance per traffic class computation? What do you have in mind?
Like I said, what you have there is an index, assigned semantics. We can say DHCP, not DHCP, DSCP bits, I don't care, something. People have to bring the stuff. I mean, this is routing. It shoves information around. The semantics, especially for this kind of stuff, are up for the people who understand, what will benefit this traffic steering.
So again, today in any routing protocol, the distribution scope is adjacency, right? You don't go in sub-adjacency information. Traffic class is kind of substrate of this. Do you foresee signaling of information per traffic class rather than adjacency? So
Yeah,
context would be some abstraction that is below adjacency.
I don't foresee the need. Well, so we should jump back in. I didn't. You would have to pull up the ASCII port of the model because I don't have it precisely specified. But basically, so the encoding is like that. This additional node type element says, here's a link ID. Under the link ID, there is a bunch of generic things, traffic class independent. How much total bandwidth? I forgot, look it up. And then it says, here are all the traffic classes, and here is the metric per traffic class. How much bandwidth is still available? What are the losses and whatever. Pretty much copy paste from ISI's traffic engineering plus some thinking. So that's the resolution I see. And then you have per link, per traffic class, you have the traffic engineering info, and go do with it what you want.
Okay.
Unless there are better ideas in the room. And I agree that the traffic class semantics, it would be beneficial if we globally agree, right? And it's not locally, everybody kind of tries to figure out what the traffic class means, the 0 or the 1, yeah.
So traffic class semantics, traffic engineering are very different than traffic class semantics in basic forwarding. I think something we need to discuss with the working group and do the right thing.
I mean, structure is here, and I didn't want to fight the semantics battle. I was thinking how the hell get the protocol to actually shove the stuff around in an efficient manner and get us what we need for the computation, yeah.
Cool, thanks. Okay. Really interesting work, and I'll potentially join you, maybe.
We'll see. Yeah, I mean, additional information is boring, but the node-bound computation and the prefix preference disaggregation is interesting, right?
And potentially draft would benefit from some better explanation of what you're trying to do. As usual, it's pretty cryptic. In
Well,
first.
the draft is more explicit. Here, I'm just, telling you a story. I don't want to slaughter you with details, and ASCII diagrams because it's pointless, right? Hey, Sandy.
So yes, I'd like to confirm, Sandy Zhang DT, I'd like to confirm that this computation is not for any specific flows, right? It's just for some links bandwidth use or something else, yeah.
Per traffic class, I think, I think the draft says something. If we start to go into per flow state on the async, we're gonna die. It's epsilon networks. I mean, people tried it to no end. Economics of this kind of stuff simply don't work. Plus the amount of information you have to shove per flow will make whatever you come up with a total pig, right? What you need per flow is on congestion, the destination to source pushback. Whether this pushback should be per traffic class and so on, I don't know, because that's CAC admission control, and that will run surely on layer 2, because L3 is simply too slow. So it's kind of like IEEE territory. And there's lots of work on this ongoing, but there are different approaches like the plus stuff, do in-band telemetry and don't push back. I'm agnostic there.
So both types of congestion signaling are important, and they interact with each other in very interesting ways. So usually you would run congestion control from the endpoint, but then when there's change in some resource in the network, you would like to be able to do some much higher level rebalancing across. And practically flow, as we know it today, is going away in this kind of network. They don't have 5 tuples anyway. So
because I see that this extension is for tie, prefix tie or something else, prefix preference tie. So it will advertise with prefix, right?
It's
so,
prefix based, yeah.
Yeah, so it's specific to some flow?
Seems
like.
Actually, the preference is per traffic class.
Per
So
traffic
the
class.
prefix preference can push southbound. I know I'm omitting details, or read the draft. I paraphrase Yakov. The push is per traffic class. So a node can say, look, prefer me less for this traffic class. I'm okay on this traffic class.
Oh, so I see. So it's per traffic class per.
Yeah, so for me, the max resolution we can run routing protocols is traffic class. Everything else, like per flow or finer grains, is just wet dreams, doesn't work. Simply a long discussion about, what can you practically implement as a routing protocol, no matter how much CPU you have and PAV and all the tricks.
Sandy, and it's a good abstraction because the prefixes are equidistant. Traffic class gives you a FEC of all prefixes of same type that should be treated in the same way, similar to MPLS FEC.
Yeah, it's MPLS FEC. It's 129 in a sense. I mean, I didn't try to invent that stuff. People spent half a lifetime. And the PC working group is dealing with all these computation issues. So I'm basically riding on the coattails. I mean, I know a lot about that, but it's not something I want to worry about, right?
So if this tie will only be advertised on northbound, or it can be also advertised from north to south.
So careful, right?
Careful.
Just like negative disaggregation works, this works the same way. Nobody sends around prefixes. You look at the topology, you look at the load on the topology, and you decide that the guys at the same level can do a better job for this prefix on the traffic class, because you see on this specific prefix, you're completely being overrun. And then you advertise southbound is more specific, saying, look, on this traffic class, looks like I'm being hammered, so my preference goes down, okay? It gets tricky because it's a mixture between what you see advertised as this traffic engineering metric and your local load, because we can start ship around Q occupancy. In the routing protocol, it's simply, before the stuff arrives, you can throw it away. That's known since McQuillan 1956, okay? It's that old. And nothing changed. Like, yeah, everything is faster, it doesn't help you. Because now, yeah, you have much faster CPU, blah, 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 but now you have 400 gig links shoving crap and not a 56 kilobyte link, right? So that's why I said the computation merits a lot more text, right? But don't forget, it's a fully distributed computation, right? Everybody looks kind of what is available as traffic engineering metrics, and they can sprinkle a little bit of the local load, and they decide push the traffic off. Okay, so it's very coarse, but yeah, I mean, Jeff seeing that, I mean, it's nothing new. We've seen that on, call admission control on ATM networks and so on. You cannot do per flow. You simply cannot disseminate the information fast enough through the network, except some congestion pushback per flow, right? And that's simply the reality is what we can build as a technology. If we talk cellified fabrics, the life would look much better. If we had, like a credit control, right? But then we basically start to build InfiniBand.
Yeah. Seems like I
exactly.
saw some files from.
Right, and InfiniBand is basically ATM with a little bit of a different polish. But you end up in packet fabrics suck. They're cheap. That's about all that you can say for them. If you really want to do proper traffic engineering, you always end up in a credit-based system and in a cellified thing. Because only with cells, it goes beyond, it goes into things like, head of queue blockings, right? And stuff like that. So it's actually switching, it gets down to like, how do you run a properly switching metric? So you get the throughput and the delays that you expect. And pretty soon you end up cellifying. I mean, it's just the way, the perverse reality works, which pays all our bills. Okay.
We have Dima in the queue.
So we may need to add some more detects in it because
I'm saying
yeah.
that it needs more text. No, I'm saying it needs more text. No, now he suppressed my thingy. Look at this. I can't even move the thing.
You move too much. Dima, go ahead.
Hey, Dima.
Hey. Can you hear me at least? Because okay, it just takes some time.
Yeah, I hope it's not all that you have to say.
Yeah, try to talk slower and louder.
Yeah.
And don't blink your eyes. It needs a lot of bandwidth.
I will try to blink them slowly. Thanks. Yeah, Tony, I like your sessions because it allows to discuss some tangential but very important stuff. So first of all, I totally agree that what you described, it's useful, but it's like slow changing mechanism, and it's better to work in tandem with data plane adaptive routing, which is in context of IETF should be called adaptive forwarding actually, and it's probably a small task for future IETF to distinguish two things. And it's totally a real problem because many fabrics spend a lot of time being not totally symmetric, either because of incremental deployment or failures, or because it's something like Dragonfly. So it's useful to have a mechanism which will provide an initial hint how much traffic to allocate per direction. But if you want to react to actual congestion or queue state, it shouldn't be done on the control plane. I totally agree. And just, well, to have some hints on in well-designed data centers with small buffers, empty queues, round trip is on the order of 10 microseconds. And queue condition changes on the order of several RTTs. So basically to have some decent up-to-date queue state, we would need to do 10K or more updates per queue, per link for the data centers. We cannot do that in the control plane, obviously. And another thing is that, and probably it deserves some note, is that when we computed some load balancing formula, how much traffic to allocate per direction, especially in multi-stage claw or similar topology, not on the leaves, but on the first level spines. We usually use half the links for northbound radix, basically half links down, half links up. And we are load balancing over all those half links. And now the next problem is that if we look how chipsets are implemented, size of ECMP group is usually half of the number of interfaces per box, and granularity is like one record. Some new chipset can do more flexible allocation, but on previous generations and even many modern generations, basically, if we have 64 uplinks and we work with 64 buckets ECMP groups, we cannot really do something granular because, well, we can only have 64 records. We can do twice as much in one direction than others and not use one, but granularity is a real problem, especially on middle layers like level 1 spines.
Yeah, I'm all with you. On the second point, it has nothing to do with the specific protocol you run. No matter what you do, you just cannot stick it into silicon.
Yeah, it's just that people should be careful what happens between the point when control plane calculated something and we try to install that in the hardware.
You know, control plane is wine. You built it to last for a long time. The chips are like milk.
Oh yeah.
Right. I got every year the stuff that goes twice as fast and costs half. No, we can talk about it. Like
on a good year,
for 40 years, right? And look at ISI, 40 years, and we probably long not done. So I'm building the stuff for something where people will build the silicon that can do decent stuff. The first point was more interesting. You can call it what you want, like this link adaptive routing, blah, blah. Yes, look, there I can only say your mileage may vary. The first, I think it is completely misguided to stick it into IP. If you want the maximum speed, you go L2. Point. Okay? So it's already, we have a lot of Juniper co-authors on the draft, so I shouldn't be too vocal, but to stick it in UDP, you're basically already, you know, tripping over your own feet. So if you stick it into L2 and you start to shove out queue utilization and so on, there are already some technologies, and yes, that can be done. And I know there's silicon that, you know, does something with it. All fine, but it's basically looking through a peephole, right? If you have a fabric that has, you know, just 3 stages, fine enough, sure, every path is 2 links. Once people start to build fabrics, you know, all the way down to compute stuff, and the compute stuff itself has another claw underneath, right? And you end up with 7, 8 stages, your mileage will vary. And you get very quickly into oscillations with this kind of stuff, right? As long as the load is low, well, anything works, right? The moment the load starts to go up and you get, you know what Nash equilibrium is, of course, right? So you basically have a lot of actors. It's not the problem even that they're greedy. They have extremely limited information, and they will step onto each other and oscillate the system. At a certain point in time, the whole thing is a lava lamp, and that's fine, right? So I'm looking for something where we can distribute the information well enough so you can push from destination back to source in a coarse manner, right? While the whole thing scales, because of course we can stick everything in IGP and go, hey, go Mary, right? And that will melt down predictably. So this, I even think the prefix preference idea is kind of your own, you know, manure that, you know, I picked up in terms of ideas. You were kind of talking about that, right? And I just kind of ran with it because I couldn't find anything better that will scale, right? So yes, so I think it will be a wild mixture depending, like you say, on silicon and what people strip together. And lots of these people have very little experience, and they will try wild stuff. And you know, the usual whether stuff works by now depends on the definition of works, which varies all the time. So this is an attempt to do very coarse balancing around in a very scalable manner. And the underlying stuff, well, I see what comes out of it, you know. That's how I see it.
Yeah, good. And actually, I agree because working with approximately slowly changing traffic patterns is a totally valid problem. There are like daily patterns in traffic and so on. It totally exists.
Well, look, if your patterns are slowly changing and very fat, which you see, I consider that total utter illusion. We ran the Google thingy, right, or whatever, Amazon, where 90% of traffic goes north-south, and everybody said like, well, that's the pattern, let's optimize for it. And 3 years later, 90% was east-west. So if you know that your patterns are fat and long-lived, and ideally you can predict the arrival rate, and by all means build a controller. It's by far the best solution. Nothing distributed can ever, I mean, it's the Nash equilibrium discussion, right? That's exactly it, right? So my belief is, and that's why all this distributed stuff, one is that we are dealing with stuff that changes the arrival patterns all the time. And hence, all these assumptions are breaking down pretty quickly. But we'll see, see, AI, that's why my first thing says, let's chase AI. I think AI is, what did you say? Every problem at the end is distributed linear algebra.
Exactly.
But depending on how you fold your tensors, the distributed traffic may look drastically different, right? They may not look long-lived at all. So, yeah.
So I think we should have kind of extended discussion on this, maybe interim, but practically it addresses some issues that it didn't intend. So I'll provide some text to it, but practically you're looking at everybody else's state to decide how good you are, right? And granularity, you don't have 2 links here. You have 128, potentially 250, 60 links, uplinks to reach destination over same traffic class. So what's really interesting is ratio of data you could send to you versus others. And this is it almost perfectly suitable for that. Again, I'll provide more text. I don't think.
So my first design, which I threw away, was actually you telling the leaf that the other guys suck. And I threw it away.
No, you definitely want to do distributed computation.
Right. This is better distributed computation. We're more responsive saying that you suck, the way you see it, yes. Rather than talking about other people who will tell about the other people the confusing information that doesn't match up. And the next thing you end up in Paxos protocol, right? Okay.
I think it's really, really interesting work that can bring whole reef discussion to very different level. And I think we should move on.
Yeah, I'm done. You Thanks, guys are pestering me.
Any other questions, comments? Hopefully some tomatoes.
Thanks.
No tomatoes?
I pass on tomatoes.
Oh, thanks.
Oh, I take donations. No, not really. I have enough t-shirts now. Okay, thanks.
Jordan?
Yeah, I'll try and save some time for you, Jeffrey. Okay, just wanted to give a rough update for the key value tie.
Jordan, try to get a bit further away from the mic.
Jordan, don't worry about time. Just take whatever time you need. My presentations can be skipped, no problem.
Okay, how's this, Jeffrey or Jeff?
It's okay now. So again, try to be a bit further away from the mic, because otherwise you're overloading it.
Yeah, not too much I can do with that. Okay, so new in version 1. We introduced the new key subtype, and we have a couple of normative language fixes and boring things like references and editorial bits. Next slide. So we had some discussions with Jeffrey that revealed a new problem with respect to how we use the key identifier. So currently, we can kind of think of the key ID as a TLV to some degree. So this by itself it doesn't provide an optimal way to distinguish between similarly structured KV ties that might want to carry different information. Example would be we can determine who the originator is when we flood KV ties northbound, but if we need more granularity than that, we need something else to signal it. So we introduced the key subtype, which is kind of like a sub TLV. Next slide, please. So this is from the draft, including the new one, right? So you have the key type and the key identifier at a high level. It's 3 bytes of space. Hop to the next slide. And now instead, for a couple of different key types, we steal a byte from the old key ID and give it the subtype. So basically for well-known and experimental, that's where we do it. So we give it 1 byte of subtype, 2 bytes of key identifier, and the OUI key type will stay at 3 bytes because 3 bytes. So the subtype is technically optional, but must be used for well-known and experimental. And there are cases, like I think we'll see on the SRIFT stuff, where we can still use a new key type for applications like well-known applications that might want to use the full 3 bytes of space. Okay, next slide. The good news is this doesn't really change anything to what we're already doing in terms of implementations. So using the example of AutoEVPN, the key value structure from the old version in version 5 is on the left, where we used all 3 bytes of the key ID to say, we have a KV tie, but we want EVI specific information on that node. And we might have, 10 EVIs. But in reality, we had language in the draft that said, we have to encode that EVI ID into the last 2 bytes of the 3 byte key identifier, which effectively makes it look like what's on the right, which is what the key subtype reflects in the draft. So we have that well-known to signify, an EVI, and then we can encode that additional granularity in the last 2 bytes. Okay, next slide. Other than that, there's some normative fixes, minor stuff. The key target, the Bloom filter stuff, it was optional. We just made it normative. And then there was a couple of comments about the southbound tiebreak key value pair and what its use was. And basically, we emphasize that it's used for implementations to kind of test their tie-breaking behavior. And we folded it in the new subtype structure as well. And like I said before, references, so forth. Next slide, and I think that's it for this one. Questions, comments? Okay. Whoop.
Sorry, didn't get into the queue. I think we need to explain the key target and also Bloomberg filter with a little bit more text. I don't know, is it the main spec or is it in the key value spec? If it's not in the key value, we should expound a little bit, because people talk to me and I thought it's fully obvious how a Bloom filter works, but I was mistaken. The other observation is that when we were designing that, we screwed up mildly. We should have made the key 64 bits, because now I see more and more use cases where the 3 bytes will be tough on the collision. So those are the 2 observations.
Yeah, I had the same experience with the Bloom filter stuff too. Anyone who talked to me, well, same experience.
So the idea is to make key identifier wider. What's the plan? Jordan?
Sorry, I'm trying not to kill the mic. We'll kind of talk to Tony and see. I'm not. I know, Jeffrey. We talked about the key space being wide enough for the asterisk stuff, but 3 bytes in that case works. So we ended up just getting a new, well-known for that. But obviously, I take Tony's word at face value that there's other applications where we might end up with collisions. So personally agnostic. Depends what Tony thinks too, as far as implementation and what it would take with base spec.
So there's no need to rush that stuff, especially because with the auto VPN implementation, auto fabric implementation, and the customers now showing interest in some of the stuff, more and more stuff shows up on this key value. So if you ask me, I mean, we're talking about the generic key value draft or just the auto VPN key value? No, generic key value, right?
Generic.
Yeah, I would let it stew, add some more good tags for the bloom. Stuff's implemented, stuff works. The key is too small, but it's after the fact, okay? Because the base spec is out. Is it a tragedy? No, because you can manage the collisions on 3 bytes. It's just tedious when you implement it. It is like the tie ID and so on. If you blow the stuff to 64-bit, you can go wasteful. Life's easy, right? It's like the IP address. This thing is, you need squeeze. But I would just let it sit there until auto fabric, auto VPN is cooked, possibly interrupt, deployed something, and then it's time to kind of tie up the key value thingy. Right now, I'm not seeing incorrect. I'm seeing already use cases. People talk to me. So one of them is people want basically to run a DHCP server on top. And they want to use the key value basically to push DHCP assignments through the fabric. And I'm reluctant to write that.
You already have protocol to do this. It's called DHCP.
Yes, you do. But okay, so the problem with DHCP is that any kind of proxying really sucks. And even the best implementation in the market have only 1-for-1 redundancy. And if you implement the stuff in the Rift, you don't have any proxy configuration problems, which can really drive you bats on proxy DHCP. And this would give you, unlimited redundancy. Okay, but stuff's tricky. So that's one that people pester me forever, right? The V6 loopback assignment, as we have now into all these auto technologies, works fine. Collision is basically almost impossible, even on very large fabrics. But the IP stuff immediately stops on each other feet, so you cannot really hash it. And you basically need to run something like DHCP server from the top, which is really ugly because you have, of course, synchronized state between the tops, who assigned what. So basically, you'll have assignments which compete, and then the leaf will push up to all the tops saying, that's what I took, now everybody stores it. And then, of course, comes the between reboot stuff, right? So the leaf, it's all the DHCP problems again. So that's one thing that people pester me forever now. There was another one which I don't remember. It wasn't. So the other use case is where people have DHCP servers on the top of racks, and they want to shove this information up because otherwise all their provisioning systems cannot keep up with the stuff. So they end up very often, in a situation where some top of racks reboot, some servers reboot and so on, and the DHCP is piddling around, but their system is so slow to update that they basically end up with no routing, wrong places, all kind of weird stuff. And this will be an extremely fast mechanism to redistribute that from the top of rack.
I hope we will never see this in protocol.
I am reporting almost independently of what I'm thinking about, right? I think the second one is okay because there actually good amount of customers are stripping atrocious systems to deal with this problem. I mean, once you pull Rift all the way down to the host, well, you still have the address assignment problem if you go v4, right? So yeah. Okay, so I would let it stew. I think a bunch of things are cooking. Auto EVP and Fabric is not really deployed, has been implemented, but it's still people come up with ideas, kick the tires. So no rush to go and get this thing RFC'd. Methinks, okay. Plus the Yang is still in flux. So Jordan was kicking the Yang down the road. I was commenting some. I don't know what state we are with the key value store on the Yang. So it's my take. No rush.
Let's move to next presentation.
Yeah, and this one's quick anyway. Yeah, just hop to the next slide, please. Boring change, but an important one. So the previous version, as we were writing and implementing everything, we, instead of using EVI, Jeffrey correctly called out that, or we were calling it MacVRF, which, as Jeffrey pointed out, would be very confusing to those who actually do EVPN. So basically, we just changed any reference to MacVRF to EVI where it made sense. So no functional normative impact, but makes things clearer. Next slide. And then we did adjusted to the key subtype for both key value pairs. So we have the global key value pair that's, again, the language already stated this, well-known states it's global, and we encode the Fabric ID into the last 2 bytes. Next slide. And same as this is the same as the example I used in the key value bit, where we encode the EVI ID into the last 2 bytes. So same thing there. Yeah, boring stuff. The registries are updated to reflect the new subtypes, references, and so forth. That's it.
Questions, comments? So now it's you, I guess.
Well, so we had very good discussions on the earlier topics. We're running out of time for some updates I was going to do, but I'm happy that we spend more time on those discussions. So I'm going to skip my presentations. Those are just mainly just updates. Well, no, it's good that it's okay. We can skip those. So for the remaining time, we talked about the rechartering. We talked about the proposed charters before. We were going to wait until we finish all our major initial milestones before we officially kick off the rechartering process. I think we're probably at that stage now. Let me pull up the proposed charters we had discussed before. And we also added some milestones there. And so, Jim, do you have any, do you want to say something about this?
No, not really. To be honest, I haven't had much time to really look at it. I know we had a conversation about adding milestones, which you've done, but I haven't even looked at those yet, to be honest. But I think as long as the working group is happy with the text, then I'll review it and start the process, because the base spec is already there now. which is really what I was waiting for. So I'm happy to move things forward once the working group tells me, okay, that we agree upon the text, and then I can take it through the process.
Okay, thank you, Jim. So I guess now is the time for the working group to really carefully review the text and see if we want to make any changes, or we just ask Jim, our AD, to move it forward. Well, we don't have to do it in this meeting now, just mailing list, offline review and discussions. Yeah.
It's pretty straightforward.
I think I saw Tony walk into the mic before we,
No, it was the charter.
not about charter, right? But
Yeah, I know. I want to ask about charter.
okay, yeah, go ahead.
Tony, go ahead if you have questions.
Me? No.
Yeah.
I wanted to ask where we are with the charter, but. I
So
see.
we'll send the email to the working group list, obviously, to ask. And this is kind of the charter that we think is making sense. And this is something that we will propose to OSG.
Yeah, nothing to add. I think it makes perfect sense. And we see, who works on what and how much of the stuff will be moving forward and how much, dies on the vine. Yeah.
Okay, I think we are pretty much done. Thank you, everyone, for being here, and we will see you in Dublin.
Okay, thank you, everyone. Bye.